Thank you for joining me for Engineering Design for Young Explorers. My name is Christina Garcia. You can find my presentation on my website, edtechinspirations.com, and also all of the activities that I show you in here. If you go to the Engineering Design tab on that page, they're there for you to download and use however you choose. So a little bit about me. I'm in my 20th year of teaching. I've taught K3. I currently teach a K1 loop, and I love it. I have first grade this year. In 2014, I became a Google certified trainer, so I love all things Google. And I'm currently working on my master's degree in education on the effects of blended learning in a first grade classroom. So year 20, I really wanted to change things up, and I wanted to create a more student-centered environment. I wanted it to be a classroom where the students were just learning from me, where we were learning and teaching each other. And I have to share that this has been the most fun year that I've had in a long time. So what did I do? I knew the next generation science standards were coming, and I wanted to get a jump start and ease myself into them so it wasn't so overwhelming when they were fully implemented. I chose the engineering design standards for K2 to begin with. And if you go on the Next Generation Science Standards website, they have all the standards there. And what's nice is they have connections to ELA and math. And these are just the engineering design standards. And like I said, they cover grades K2. And there's also an app for that. Mastery Connect has a wonderful app that has all of the next generation science standards in teacher-friendly language, and it's free. So why engineering design? Because the younger students need experiences with engineering and technology if they're going to succeed in our 21st century world. And they need that hands-on experience. A lot of times we're so busy with teaching language arts and math that those hands-on experiences are the first things that we cut out because we don't have enough time. But those experiences are what the kids learn the most from. They're the things they remember the most. What are the benefits of engineering design? Building science and math skills, but it goes beyond that. You're also building reading and writing skills. You're building classroom equity. I have a wonderful story to share with you a little bit later about classroom equity. It generates interest in vital careers. We have to prepare our students for jobs that don't even exist yet. Engineering design increases technological literacy, and it fosters the ability to engage in the design process. The engineering design process is a wonderful problem-solving process, and this is what we use in our class. We start at the top, and the students ask what the problem is. They imagine, they'll brainstorm solutions to a problem. They choose their best idea. Once they have their idea, they draw a blueprint. They list the materials they're going to use, and then we go and we create and test out our plan. Afterwards, we come back and reflect what worked, what didn't work, and how can we make it better. I'm on our language arts adoption committee, and this week our story was about inventors. And we were going through the vocabulary on Monday, and two of the words were imagine and improve. And the kids automatically made a connection. Hey, we do that. I have the engineering design posters on the wall, and they pointed to them. So they were already able to make a connection because we had been using this process all year. Engineering design promotes 21st century skills. The creativity, the communication, the collaboration, and the critical thinking just happen. When you create these experiences for the students, they just happen, and it's amazing to watch them work with each other, help each other, the ideas they come up with. When we started at the beginning of the year, I started with engineering in our everyday lives. This is a wonderful series of books all about engineering. And they're easy reads. They have lots of vocabulary, lots of pictures. We went through and we talked about what technology is. We talked about tools. We talked about what engineers are. And then they went back and they wrote in their own words what these meant to them. So technology is a thing that makes a job easier, like a vacuum, a scooter, a bike. Tools are things that help you, like a nail and a hammer. An engineer is someone who builds instructions to make a doghouse. Those are their meanings. That's how they connected to those words. ScribbleBots was one of our first projects that we did together. And I was lucky enough to have my DonorsChoose proposal fully funded, so I was able to buy hobby motors and battery packs, and that's what we used for these projects.
Now it is.
And this is our first real big project, so I was able to sit in small groups and show them how to connect the motor to the battery pack. And I bought battery packs that had an on and off switch because it was easier for students. So we really took our time learning how to do that. They decorated the way they wanted it to. And we did this over a series of a few weeks. In the end of the project, I had to call parents in because we just needed to get them done. But going back to that class equity, I have my students' ability group for reading and math, but in science, they are heterogeneously grouped. So we all have those students that struggle academically. One of my students that struggles was the first to get his robot up and running. That was his strength. And the pride on his face, the smile, just the way he felt inside was priceless. And all of the other students ran up to him and they were trying to ask him for his advice on how he got it to work. And so now anytime we go through these projects, he's the first one they go to for help. So this was a very fun project. Afterwards, we went through and we talked about, well, if someone wanted to build it themselves, how would they go about doing it? So they wrote down their procedures. Get a plastic cup, put your name on the cup, choose 3 or 4 markers on your robots, put your markers, and you didn't see this before, but he wanted to quit. And he kept going, and I asked, are you glad you didn't give up? And he said yes. So these are the supplies that we used. The hobby motors are about $3, and the battery packs, if you get them, anywhere from $2 to $3 a piece. You can get them in bulk on Amazon. Scribble Buts wasn't my own original idea. I had gone on YouTube and looked for different videos on how we could do this. And at the bottom, I have a playlist that you can go to and see the different videos, and we kind of meshed them together and made them our own. In this video, they use a clothespin, and we tried that, but it didn't work. So we came up with just using the electrical tape as a propeller. We cut it in half, attached it to the motor, and it worked for us.
For this experiment, you will need a AA battery, one simple motor, which you can...
The next project we worked on, we were studying fairy tales. And I found this activity online, and I tweaked it like we always do, and we make it our own. So it became the 3 Little Pigs Extreme Home Makeover Challenge, Fairy Tale Edition. So they had to design a house that could withstand the huffs and the puffs from the big bad wolf. I gave them lists of supplies that they could choose from. We began the engineering design process where they had to first draw their blueprint and they had to label the material. Then they had to list the materials that they were going to use. So here they had spaghetti, and they were going to use Play-Doh. Afterwards, we did a reflection, what worked well, how did you change your design, and what didn't work well. The Play-Doh worked well because it kept sticking on. The tape stuck well because it was sticking. How did you change your design? We changed our design with popsicle sticks. I allowed them to change their materials. If it wasn't working, to me, what was more important was going through the process than sticking to what they had originally started. What didn't work well, the spaghetti didn't work well because it was falling apart. These are the suggested building materials that we use. Of course, you have the Big Bad Wolf made out of an old hairdryer and some fabric. They were able to choose from spaghetti, popsicle sticks, and straws, and marshmallows, dots, and Play-Dohs to attach the pieces together. They got to choose one item from each group, and then I gave them tape, and it didn't count as one of their building supplies. So in the video, you'll see those 21st century skills just happening. And all I did was monitor and observe. They really didn't, this process they went through all by themselves. There's our materials, and they chose. Now we had marshmallows. We found out halfway through that they got real sticky from being handled. So those that were using marshmallows switched over to Play-Doh.
And the Big Bad Wolf says, I will.
And their designs weren't three-dimensional, and they didn't have roofs, but they went through the process. And we had a good discussion about things don't always go the way we plan. That's why we take them back and do it again.
And also don't mix the colors with
So I think we ended up with all popsicle stick houses at the end. But just watching them, trying to put it together, working together. These two had it down.
Clothing is fun.
And so at the end, we tested all the designs.
And the Big Bad Wolf says,
Only one brick.
he's out of breath. Good job, only one stick, Phil.
So
and
that
the
was a
piggies
fun
are
activity.
still safe.
After that activity, I got the best writing from them because they had something to write about. They started writing fairy tales without me even asking them to. We did sequencing, we tied it into all the other curricular areas. Later on in the year, we went back and we did Jack and the Beanstalk. In this activity, it says that Jack needs your help. The giant is chasing him, and he needs to get down the beanstalk as quickly as possible. Design a parachute that will help Jack return quickly and safely back home. If you notice, the blueprint is a little more detailed because it's later in the year. They've done a lot of these. They're getting better at it. What I didn't anticipate in this activity was that the students were not able to tie knots on their own. So if you do it, get a parent volunteer. It was a lesson learned, but we kept on going and we finished. These are the supplies that we used. We used coffee filters, paper bags. You can use anything. String, yarn, dental floss, curling ribbon we added in at the end because the kids saw it in my tub and they asked if they could use it, and I said sure. And here's a sneak peek of how it went. These were individual projects, but they still worked together and helped each other. And they found out real quickly who knew how to tie and who did not. They're attached to Lego minifigures. And again, a lot of them started with different supply, different materials, and changed.
Okay, ready?
Pretty good. I love the sound effects on that one. So while we learned that they couldn't tie, it was still a fun activity that they enjoyed. And we had writing to follow up. My favorite part about building a parachute was testing the parachute. The hardest part was tying my Lego minifigure. I learned to never give up. So good life lesson. During Thanksgiving time, we did a Mayflower engineering challenge, and they had to design a boat that would carry the pilgrims and their cargo without sinking. So on this activity, they had to make a prediction. We used teddy bears and Unifix cubes. They had to predict how many pilgrims they could take and how much cargo. Again, we started with our blueprints. Afterwards, we had our reflection. Did your boat sink or float? My boat sinked because it needed higher walls. My boat floated. We did this activity twice because the first time they all sunk. My boat floated because we added 1 cargo and 2 pilgrims. And we did higher walls. You'll see in the video all of the pilgrims they had on their table that they thought they could take and found out they couldn't. My favorite part was when we were building with Play-Doh and putting the pilgrims and the cargo. For this activity, we used Play-Doh, teddy bears, Unifix cube straws, construction paper, and I used a big blue plastic pool as the Atlantic Ocean. That's how many pilgrims he thought he could carry. And they're so engaged while doing these activities. That was before we had included a straw with a sail. No, they're actually on my website for free.
Okay, what else do we have to change? Jaden?
edtechinspirations.com. If you go to the engineering design tab, it has all of these activities, the black lines that you can print and use.
Too many
You're welcome.
pilgrims. Too much cargo.
Does it come
Riley.
apart in water? They sank. So, and don't use homemade Play-Doh. It does not float like regular Play-Doh. I tried that. I was trying to cut corners, went home, tried it, and it sank. So I had to make a late night trip to Target to get. And you'll see even the second attempt, they floated for a while, but they sank. So Minecraft, if you can't beat them, join them. But I suggest that you get a Zachary. This is Zachary. He's a former student, very good family friend, sweet. And last year when the kids were in kinder, he brought his phone and he shared his designs with us. And the kids were just in awe. He was a superstar. Every time they saw him in the library, I just saw Zachy. And so he came in every so often and worked with us on Minecraft Pocket Edition on the iPads. And that was in kinder. This year, we switched over to MinecraftEDU. And the benefits of MinecraftEDU over Pocket Edition, there's an obstacle course tutorial that's great for teachers and students to learn the basics. And teachers have control of what the students can access. We were working on an animal farm project, and the kids were more, they were having more fun breeding the animals, so they had this small pen with 20 cows in them. And so what I had to do was take away the animals so that they could finish building their farm before they got them back. Creative mode allows the younger students to explore and build without all the scary things, the creepers. And what's nice about it is they're already using it. They already love it. So link it to your curriculum. And you don't need to be Minecraft experts. We put so much pressure on ourselves thinking we have to know everything, and we don't. The kids are so forgiving that they'll help you. And they don't care that you don't know. All you need to do is design the ideas, and then you're teaching and learning from each other. So this was our first project that Zachary and I put together. And going back to Thanksgiving, they had just arrived in a new world. They were pilgrims, and they needed to build a new settlement. This is first grade. Now, Zachary built the Mayflower as an incentive. When the kids were finished building their settlement and they had food, they could fly out to the Mayflower and explore on it. There's our Plymouth Rock. And as a group, we came up with Mayflower Compacts. They were learning that other groups were coming onto their property, and they didn't like that. So they came up with the rule to respect each other's properties and stay off. And those are things that they came up with. But here's our own little virtual world. And as a teacher, you're in there, and they can see you, you can see them, and they love it. There's Miss Garcia. And the creativity is amazing. I was able to build that.
Now we just need a door. Can I build the fence? The door's like the second one. No, I'm not going to.
And in the end, we had a settlement. They had built their own garden with their food. Some of them got really fancy and had water going down the sides of their houses. For this project, it was actually, I got creative and did math with some kids while other groups worked on that. And it took about a week. They build really fast. It takes us a lot longer to build. They're just placing the blocks one right after another, where I'm one at a time. But the collaboration is amazing. I can't say it enough. The creativity, what they come up with on their own. And some of them that were on their own machine, others were sharing and working with partners. But you'll see the blue, they added water. And they're up on top of the roof adding blocks. I took this project one step further and added a performance task. They didn't know what perimeter was, but they knew how to add. So I gave them the directions. As a group, determine the perimeter of the new cabin that you built, show your work in the space provided, and explain your reasoning. So Here's their reasoning. We counted 15 blocks in the front of the house. On the sides, there were 5. Next, we counted 15 blocks. Finally, we added 5 plus 5 plus 15 plus 15 and got 40 blocks around the house. So I tied that into math as well. My favorite part was working together to build a house, and I learned that it is not easy to build a house. The hard part was counting the blocks on the bottom, and I have corn, potatoes, carrots, and water around to make it grow. Minecraft Selfies. This was a fun art activity that we did in Kinder last year. When I do it again next year in Kinder, use smaller graph paper. You'll see they started on just a regular size piece of graph paper and they drew themselves and they colored it. Well, then they had to transfer that smaller piece into a bigger piece using 1-inch squares of colored paper. So they had to go row by row and count how many pieces for their arms, how many for their shirt, and how many for their arms. And this took them a while to do because they were so large. But once we got started, we had to finish. But in the end, we had these wonderful pictures. They loved them. And here are the directions for that activity. You'll see them working on them. And it was really fun. We read a story about going to the moon. We were learning about space. And they talked about the Lunar Rover on Mars. And I thought, well, that would be really cool to build a Lunar Rover. So I searched around online and I found a video on a battery-operated car. Well, we already had the motors and the battery packs that we had used previously in the year, so we were going to use those for this project. Now, if you notice, this student did a side view and a bottom view in his plan. I didn't tell him to do that because when they watched the video of what we were going to do, he said, well, we need to show where the straws are on the bottom to attach the wheels. So he did side view, bottom view, or they worked in partners, sorry. And then most of these materials were already pre-planned. They added a satellite, electrical tape, and I found some little flags and stickers that they could use. And they went through their Lunar Rover procedures so that someone else could build it. And this is how it went. What was nice is, and I didn't realize it at the time, I was glad at the beginning of the year I had taken the time to really show them how to connect the motors to the battery packs, because I just had to give them a motor in the battery pack and they were gone. They did it all by themselves.
It was on off.
The only thing I had to help them with was gluing the wheels, the caps, yes. The glasses, the safety glasses, I actually got those at Dollar Tree. Yeah.
Your tape off.
And they're really good at cutting the electrical tape. They come and get the supplies as they need them. I don't have to hand them out because they've learned what they need and how to do it. And now we're testing it out. He gave it a little push. This was an individual project, but they still found each other for help. Hers was going sideways.
I'll show you where they are. Mine is tipping over.
And they actually worked. Afterwards, we used Google Slides and Google Drawings to put all of our facts together and create a presentation of what we learned about space. Here's a video. There's another playlist. I used more than one video and we meshed them together. Here they used just one battery. I have the battery packs with the on-off switch just because it's easier for the students. And they watched this, they watched the steps and saw what they needed to do. The hot gluing I did for them, but that was pretty much it. The rest was on their own. Oh, and the holes in the caps. I did that for them as well, but I did all of those ahead of time so they could just come and get them as they needed them. PVC. We just received these a couple months ago. I was lucky to receive a grant from our enrichment association in our district, and I was able to buy 2 PVC. And we made our own grid because we were on a budget. They do sell the mats for PVC, but I use painter tape, and you'll see that is just a dry erase marker that comes right off with the mop. And we created a maze. And the controls are on top of the Bee-Bot, and you program the Bee-Bot to get through this maze. There's also a Bee-Bot app, and that's what the kids used before we got the actual robots. So they were able to transition programming the robots easily. And it's not easy to do. In addition to the Bee-Bots, we have Dash and Dot. Our first Dash I was able to get through my DonorsChoose proposal, and then we got a second Dash through the Enrichment Foundation grant. The little one on the right is Dot. Dot does not move, so we usually use Dash, and we named the second one Dodger.
That's kind of a cool greeting. Let's try another one.
Wonder Workshop has apps for these robots. Here he's trying to maneuver them just around the blocks. This is when we first started using them at the beginning of the year, and they're just maneuvering them around the blocks. Later in the year, I want them to start using the Blockly code and programming them. So the app on the Wonders Workshop site was a little bit too difficult for the students, so I found the Blocklify for Kids app, and it walks them through first how to program in a square, and then they get more difficult. They learn how to move his head, how to make his eyes blink and change color. Do it again. And you can see her dragging the blocks of code. And they work together in groups. We have stations on Friday. I use Fridays for science. The kids call it Fun Friday. Here, we took just our regular square and we divided it now. And we had them visit the Grouchy Ladybug, then Tacky, and then they had to end up at Curious George. And so they're inputting all that code into the tablet on the program, with the program. Then we made our grid a little bit bigger and a little more difficult. Dash comes with a xylophone app or accessory. I had a parent come in one afternoon and work with the kids, and I didn't even ask her to, she looked on her phone and found songs for a colored xylophone. And so we printed some out so that the kids could use those to program Dash to make music. When we were doing our space unit, we talked about the tools or the equipment that astronauts need to take with them to the moon. So we wrote food, camera, and tools. The kids had to first draw the path that they were going to take to collect those materials. after they did that, they took their path and programmed it with the program to control the robot to pick up the items. So here they are testing their code. And they could draw the path any way they wanted. They could have picked up the camera first or the food, but they just had to go from Earth to the moon. And there's part of their code. We did a Lego racetrack, and this was a coding unplugged activity that we didn't use devices for. The students actually created a racetrack on Lego base plates. And the only thing was they had to have a starting line and they had to have a finish line. They created a car that had to go through their racetrack. From there, they got graph paper and they had to recreate their design. Then they counted how many spaces they had to go to move their car through that racetrack. So up at the top, they go up 10, then they go right 12, and they work together on this in a group, and this was all done unplugged without a device. Going back to that student-centered environment that I wanted to create, I got a piece of shower board, stuck it in the corner of our room where the students could just go and draw. When we were studying bats, they drew and wrote facts about bats. I really gave them no direction. It was pretty much free for all. Whatever you wanted to do, you could do it. I also made a Lego table out of a little square Costco table and Velcroed base plates to the top so they had a Lego table to work on. I got this idea from a teacher in our district, and they're just PVC pipes cut in different lengths using the elbows and the connectors, and the kids put them together and they can create whatever they want. It's pretty much your imagination, whatever you can come up with. And so you'll see they get real creative, and in the video later you'll see some of their designs. The only problem is this. When they get stuck together, the kids will tug at them, and you have to teach them how to twist them out so that they don't fall back. For computer science, we do the Hour of Code. Any Hour of Code fans out there? I started 3 years ago, the first year, and the only app that I could find on the iPad was Codable. And so the next year, they had more apps available, and we were on Tinker. And then this year, they added even more, which was wonderful. They had the Star Wars one, Minecraft. Tinker has a lot for the lower grades. And so I created a web mix of all the different coding activities that the students could use the day of Hour of Code, and they still use them now because they're still available. So this is one of our choices on our Friday science stations, is to work on the coding apps. PBSkids.org has some wonderful engineering activities. And what's nice is the kids know a lot of these characters, so they can relate to them, and they like them. Through the grant, I was able to buy and find some wonderful books on engineering. If I built a car, we read that when we were doing our Lunar Rovers, because the car in the book looks like a little spaceship, and it related to what we were doing. They're just really cute stories. These are more. Rosie Revere Engineer, you've probably seen those. These ones were a little harder for the students to understand, but they still enjoyed them because they could relate that engineering and building things just like they were doing in class. And I couldn't have done all of these without having my DonorsChoose project fully funded and receiving the grant. But these are choices that you can use. MinecraftEDU, that was a self-funded one because I saw the benefit, and to me it was worth it. And in closing, in the words of Dave Burgess, don't just teach a lesson, create an experience. So are there any questions? Thank you for joining me.